We are going to talk about factor theorem. Let's try to understand what is factor theorem. Before we really go and talk about factor theorem, let's take an example and examine whether x plus 2 is factor of a polynomial x cubed plus 3x squared plus 5x plus 6. Now, in order to do this, the first step is to find what is 0 of polynomial x plus 2. To do this, we'll equate x plus 2 to 0 and hence x plus 2 equal to 0, which implies x equal to minus 2. Next, we'll move to step 2 where we will put x equal to minus 2 in the polynomial x cubed plus 3x squared plus 5x plus 6, which gives you minus 2 to the power q plus 3 minus 2 to the power 2 plus 5 multiplied by minus 2 and plus 6, which further gives you minus 8 plus 12 minus 10 plus 6, and then you get 18 minus 18, and that gives you 0. So we had x plus 2 giving me 0 as minus 2, and when we replace this in the polynomial, that also becomes 0. And hence, if you are dividing two polynomials and divisor, in this example divisor is x plus 2, is a linear polynomial, this is a linear polynomial because the degree is 1, then 0 of divisor polynomial will give you remainder, and if remainder is 0, then linear polynomial is a factor. Now let's talk about what is factor theorem. If px is a polynomial whose degree is greater than 1, and if a is any real number, then x minus a is a factor of polynomial px if pa equal to 0. So if you replace x with a and that gives you 0, then x minus a is factor of the polynomial. And vice versa, if pa becomes 0, where a is a value of x, then x minus a is factor of px. Now let's use factor theorem for one of the example here. We got to find value of k if x minus 1 is factor of 4x cubed plus 3x squared minus 4x plus k. Now, since x minus 1 is factor of the polynomial, hence we can put x equal to 1 in the polynomial. And if so, 4x cubed plus 3x squared minus 4x plus k, which is the polynomial, will become 0 for x equal to 1. And if you replace x with 1, you get 4 1 to the power cube plus 3 1 to the power square minus 4 1 plus k equals to 0, and that gives you 4 plus 3 minus 4 plus k equal to 0, and hence 3 plus k equal to 0, which finally gives you k equal to minus 3. So this is a place where we have used factor theorem to identify the constant term of the polynomial. Now use factor theorem to find factor of a polynomial. How are you really going to use factor theorem to find a polynomial factor, right? So let's try to understand. Let's assume px equal to ax squared plus bx plus c is a polynomial, and this can be represented as 1 by a multiplied to the polynomial as ax squared plus bx plus c, where you are dividing the polynomial with the term of x squared, and in this case the term was a, so I am dividing it by 1 by a by multiplying the polynomial to 1 by a, which finally gives you x square plus b by a multiplied into x and plus c by a. Now let's assume alpha and beta are 0 of px. Then we can conclude alpha into beta is equal to c by a. And now next look for a factor of c by a for which px can become 0. And let's assume the factor of c by a is r and s for which px becomes 0. So ideally pr and ps is 0. And if so, then px can be represented by 1 by a multiplied into x minus r multiplied into x minus s. And that's how you go and use your factor theorem. Now let's take an example. Factorize 2y squared minus 10y plus 12 by using the factor theorem. Now I'm going to use polynomial py equal to 2y squared minus 10y plus 12, and this can be represented as by dividing it to 2 and hence multiplying it by 1 by 2, which finally gives me py equal to y squared minus 10 by 2y plus 12 by 2, which gives you y squared minus 5y plus 6. And now let's assume alpha and beta are 0 of px. Then as per the factor theorem, alpha into beta should be equal to c by a, and in this case that is number 6. Now let's try to find factor for number 6, and we know the factor for 6 are 1, 2 and 3. And now let's examine which value or which factor value of 6 can make polynomial as 0. So when we do p1, we get 4. However, when we do p2, we get 0. And if we do p3, then also we get 0, which concludes 2 and 3 are the value of alpha into beta equal to 6 factor, which makes your polynomial 0, and hence py can be represented as 1 by 2 multiplied into y minus 2 and y minus 3. That is where you are using factor theorem, where your constant term factor is being used to really identify 0 of the polynomial, which gives you different factors of the polynomial. Now let's talk about how do we use factor theorem to find factor of a polynomial by splitting middle term as opposed to constant term. Here are the steps. In order to factorize px equal to ax squared plus bx plus c by splitting middle term, we have to write b as sum of two numbers whose product is a multiplied by c. Now let's assume alpha and beta are two numbers. Then alpha plus beta is equal to b, and alpha into beta is equal to a into c. Now we got to use this concept to get the factor by splitting middle term. And here is another example. 6x squared plus 17x plus 5. Let's factorize this polynomial by splitting middle term and using factor theorem. We can represent px equal to 6x squared plus 17 plus 5 as alpha and beta, assuming alpha and beta are the two number for which alpha plus beta equal to 17 and alpha into beta is equal to AC. Here in this example, 6 into 5 is 30. Next, look for the pair of factors for number 30. Some of the pairs for factor number 30 are 1 and 30, 2 and 15, 3 and 15, 5 and 6, etc. Now if you take 2 and 15 as a pair, and if you add them, that gives you 17, and that qualify the equation of alpha plus beta equal to 17, and hence we can use 2 and 15, and px can be represented as 6x square plus 17 plus 5 as 6x square plus 2 plus 15, where alpha is 2 and beta is 15, multiplied by x plus 5. And further, it can be expanded as 6x square plus 2x plus 15x plus 5, which you can further factorize by taking 2x out from first two term. You get 3x plus 1, and taking 5 out from last two term, you get 5 multiplied by 3x plus 1, and hence 3x plus 1 multiplied by 2x plus 5 is your factor of polynomial 6x square plus 17x plus 5. That's all on the factor theorem. Thanks for watching. You can visit us for more information on www.classagefun.com.